We're going to look at linear equations in two variables. You've been doing some graphing. What we'd like to do is write equations for lines, and we're going to use three different forms: the point-slope form, the slope-intercept form, and the standard form. What I'm going to do is just show you what those forms are and then work through some examples where we just write some equations using those forms or patterns. To put some names to what I'm talking about, our task here is that we have a graph or some information about a graph, and we want an equation, which I'll abbreviate EQN. There are three major patterns or forms that we'll look at. The first is called the point-slope form, and it's going to have a form y minus y1, and I'll explain what these letters mean in a little bit, is m times x minus x1. The second pattern we'll look at is called the slope-intercept form. And it has the pattern y equals mx plus b. And then the third pattern we'll look at is called standard form. And it has the pattern ax plus by equals c. And again, I'll go over what all those mean. What will you notice right away perhaps in these? Well, they all have some kind of generic x and y in them. Variable x and the variable y. This one has this subscript 1, and we'll deal with what that means. And they all have some numbers. M is going to stand for the slope. These a, b, and c are going to be integers that we'll deal with as we go. We're going to cover the point-slope form first and work our way into the others. Let's suppose that you are given the slope and a point for a graph. PT for point. Let's suppose you're given the slope m is equal to a positive 2/3, so that's rising to the right. And you have the point P with coordinates 1, 6. Your task is to write an equation. Well, you already know how to calculate slope. Well, let's just review what that equation looks like, so we're going to build off of that. Slope is given by the change in the y-coordinates between 2 points, the rise, y2 minus y1, over x2 minus x1. Well, what do we know in this case? We know a point 1, 6. Let's let that stand for x1, y1. The coordinates x1 and y1. And we know the slope m, and let's just substitute. Where we see the m, we'll put in 2/3. We're not going to put anything in for y2, but for y1 we'll put in a 6. And we won't put anything in for x2, but we will put in a 1 for the x1. Now, let's just get rid of the denominator on the right-hand side here by multiplying each side by x2 minus 1. Now, I'm just going to put the 2/3 in front. It will look a little more comfortable and have the same meaning. 2/3 times x2 minus 1 is y2 minus 6. Well, let's just drop this subscript 2 so that we have a generic x and y. Now we have 2/3 times x minus 1 equals y minus 6. This is beginning to look a little bit like that pattern that I showed you a couple minutes ago. Let's just flip the equation over so that the y is on the left. We're just writing it in the other direction, has the same meaning. We have y minus 6 equals 2/3 times x minus 1. This is an equation for that line in point-slope form, or in the pattern. What do we have? We have a generic y minus the coordinate that we were given, that was the y1, and that's equal to the slope that we were given, times the generic x minus the coordinate we were given, which was 1. We can always develop this equation just by knowing what the equation for the slope is, if you should forget how to get to the equation for a line, and that's why I walked through that. What we can do, the utility of this equation, is that all I need to know is a point and a slope, and I can just throw the numbers in here and be done. Let's do that in an example. Instead of working through the whole thing from the equation for the slope, suppose you're given a slope of negative 1/7 and the point P with coordinates negative 2, 4. What we're going to do is just substitute into this pattern. To write the equation in point-slope form, we'll say, okay, fine, y minus y1, that's the 4, is m. Well, that's negative 1/7 times x minus x1 minus a negative 2. And you can really stop there, but most people like to get rid of that. So y minus 4 is negative 1/7 times x plus 2, just cleaning up this little parenthesis bit. And that's it. You're done. And that's the beauty of the point-slope form. You're done very quickly. It gives you an equation that you can work with. It's an easy starting point, and there's really no new thinking involved. You can work with an old comfortable equation, which is the slope.